This is Edexcel's GCSE Mathematics Practice Test Set 2, Paper 1H. Question 1. The diagram shows the cross-section of a solid prism. The length of the prism is 2 metres. The prism is made from metal and the density of the metal is 8 grams per centimetre cubed. Work out the mass of the prism. To do this, first of all, we need to work out the volume of the prism. And to work out the volume, we work out the area of the cross-section multiplied by how far back it goes, the depth of the solid. So, if we've split this L shape up into 2 rectangles, this rectangle will be 2 times 7, which is 14 centimetres squared. And if the bottom is 7, and that is 2, then this must be 5 here. So 5 times 2 is 10 centimetres squared for there. So the cross-sectional area of this prism is 24 centimetres squared. To work out the volume, we multiply that by the depth. So we do 24 multiplied by, and it's 2 metres. So we've currently got all our measurements in centimetres, so that would be 200 centimetres. So we times that by 200, which gives us 4,800 centimetres cubed for the volume of this prism. Density is 8 grams per centimetre cubed. So if we've got 4,800 centimetres cubed, we need to do 4,800 multiplied by 8. However you do that, you can do that with long multiplication, or you can do it with the grid method. Whichever way you do that, you'll get 38,400 grams. Question 2. Dylan is driving from London to Newcastle. He will drive a total distance of 240 miles. Dylan leaves London at 9:30 and it takes him an hour and a half to do the first 90 miles. Use the information to estimate the time he'll get there. Well, if it takes him 1.5 hours to do 90 miles, if we divide that by 3, that'll be half an hour to do 30 miles. And that would mean he's doing, in 1 hour, he will do 60 miles. So his speed is 60 miles per hour. If he's doing 240 miles, then if he does 240 divided by 60, that will leave us at 4 hours to complete the journey. 4 hours on top of 9:30 would be 1:30 or 13:30. Part B, it says write down one assumption that you made. Well, we've assumed that he's kept a constant speed all the way through. Okay, so we've assumed he has maintained a constant speed. It also says what would happen if your answer to part A was wrong. So if he was slower, he would take longer. And you could also put on there, but I've run out of space, that if he was faster, that it would also take a shorter amount of time as well. Question 3. Arwen buys a car for £4,000. The value of the car depreciates by 10% a year. Work out the value of the car for 2 years. Well, this is a non-calculator paper, so we have to do this by hand. So 10% of 4,000 is 400. So after 1 year, if we do 4,000, take away 400, after 1 year, it will be worth £3,600. The following year, it will lose 10% of this value here, so we need to work out 10% of 3,600 is 360, and then we need to take that off again. And if we take 360 off that, you get an answer of £3,240. Question 4. Triangle ABC has a perimeter of 20, AB is 7, BC is 4. That must mean that the last side, 7 of 4 is 11 centimetres. If it has a perimeter of 20, the other side must be 9 centimetres. It says by calculation, deduce whether triangle ABC is a right angle or not. So deduce means show. So if this is a right angle triangle, then the longest side would be the hypotenuse 9 and the other 2 sides 7 and 4. So Pythagoras' theorem says that the longest side, 9 squared, must be equal to the 2 shorter sides added together and squared and added together. So if we work that out, 9 squared is 81, 7 squared is 49, and 4 squared is 16. If we add those together, 49 add 16 is 65, and that is not equal to each other, so cannot be a right angled triangle. Question 5. There are 18 packets of sweets and 12 boxes of sweets in a carton. The mean number of sweets in all the 30 packets and boxes is 14, and the mean number of sweets in the 18 packets is 10. Work out the mean number of sweets in the boxes. Well, altogether, there are 30 packets and boxes, each with a mean of 14. So if we do 30 times 14, that would mean there are 420 sweets altogether. In the packets, there are 18 packets with a mean of 10 in each, so that would mean that there are 180 in the packets, which if we take those two away from each other, that must mean that there are 240 in all of the boxes. And there are 12 boxes, so if you do 240 divided by 12, then that must be a mean of 20 per box. Question 6, it says, given that A equals 2 to the power 4 times 3 cubed times 5 and B is 2 cubed times 3 times 5 squared, write down as a product of powers of its prime factors, the highest common factor and the lowest common multiple. Well, I'd like to do this as a Venn diagram. So, if we put these numbers into a Venn diagram, here's A and here's B. They've each got at least 2 cubed in it, so we could put 2 cubed in the middle. They've each got a 3 in, and they've each got a 5 in. So we could put those in the middle. So in A, we've got another 2, because it's got 2 to the power 4, and we've got another 3 squared, because it's actually 3 cubed in there. And on this side, we're missing a 5, because B's got 5 squared in it. So the highest common factor are just the numbers in the middle, and it doesn't ask you to work these out, it just says leave it as a product of primes. So that would be 2 cubed times 3 times 5. The lowest common multiple is all these numbers multiplied together. So altogether, we've got 2 to the power 4, because we've got a 2 here and a 2 cubed here. We've got 3 to the power 3, and we've got 5 squared. Again, we don't need to work that out, because it just says leave it as a product of primes. Question 7. Find the value of 2 to the power 6 times 2 cubed divided by 2 to the power n split equals 2 to the power 5. Well, the top we'll simplify to 2 to the power of 9, and we want to divide that by 2 to the power something to get 2 to the power 5. Well, when we're dividing indices, we subtract them as a shortcut, so n would need to be 4, because 9 take 4 would give me 5. It says minus 6 is less than or equal to 2y, which is less than 5. Y is an integer, that means a whole number. Write down all the possible values of y. Well, this currently tells us the values of 2y, so we want to divide that by 2. So we can rewrite that as this. It then says the integer value, so it says it can be greater than or equal to minus 3. So we can have minus 3, minus 2, minus 1, 0, 1 and 2, because it must be less than 2.5 and it's an integer. Question 9. It says x and y are two numbers, each greater than 3. The highest common factor of x and y is 3 and the lowest common multiple is 36. Find x and y. Again, I'd like to do this in a Venn diagram. So if we take this number to be x and this number to be y, it says the highest common factor is 3. So the highest common factor goes in the middle of the Venn diagram. It says the lowest common multiple is 36, so that's all the numbers multiplied together. So we've already got a 3, we need another 12 in there to multiply to get 36. Now 12 can be broken up as 2 squared times 3, because 2 squared is 4 times 3. So if we're going to put those in the Venn diagram, where 3, we don't want another 3 in the middle, so a 3 must go on its own on this side, and it can't be on the other side because otherwise it'd have to go in the middle. And the 2 squares again must go on a side on its own, so that it doesn't go in the middle. So x must be 2 squared times 3, 2 squared is 4 times 3 is 12, and y must be 3 times 3, which is 9. Again, I could have put the 2 squared and the 3 the opposite ways round and had y as 12 and x as 9, but that's the answer for each of the numbers. Question 10, it says enlarge triangle T by a scale factor of half with centre 2, 0. So the centre 2, 0 is just here. To do this, we'll look at each corner in turn and half the distance to that corner. So at the minute, it's 2 across and 4 up. So we're going to go 1 across and 2 up. So that corner would go to there. This corner is 2, 4 across and 4 up. So we're going to go 2 across and 2 up. That would go to there. And the top corner is 2 across and 2, 4, 6, 8 up. So we'll go 1 across and 4 up. That will go to there. So our new triangle will be just there. Question 11. The table gives some information about the speeds in kilometres an hour of 100 cars. On the grid, draw a histogram. Well, for a histogram, we need to work out the frequency density. Now, the frequency density is the frequency divided by the class width. So, in this case, it would be 15 divided by 5, which will give me 3 for the frequency density. This one again has a class width of 5, so 65 to 70 is a class width of 5, so that will give me a frequency density of 5. This one has a class width of 10, so if I divide that by 10, I get 3.6. And the last one has a class width of 20, so divide that by 20, I get 1.2. That last one, if you divide by 2 first, you get 12, and divide by 10 to get 1.2, to make that a little bit easier. That means that going up the side, we must be going up to 5 up here. Now, you can't quite see all the individual lines on here, but on the actual paper, it's got grid lines at each whole one. So we'll just very carefully go 2, 4, 6, 8, 2, 4, 6, 8, 10, there's 1, 2, 4, 6, 8, 10, there's 2, 2, 4, 6, 8, 10, there's 3, 2, 4, 6, 8, 10, there's 4. So on the actual paper, the grid lines are much clearer than that. It's just the conversion over. So on the first one, it needs to go from 60 to 65 and has a height of 3. So 65 to 4 is just there. So I would follow this line up and it will have a height of 3. The second bar goes up to 70 and has a height of 5. So it's 70. It's going to go all the way to the top, which is 5. And down to here. The next bar goes up to 80 and is at 3.6. So there's 3 and then 2, 4, 6. And then the last bar goes up to 100 and is at 1.2. So 100 and 1.2 there. Just be really, really accurate with all of those. It says work out an estimate for the number of cars with a speed of more than 85 kilometres an hour. Well, 85 kilometres an hour is just here. So we want all of this area here. Now that has a width of 15 and a height of 1.2. So 15 times 1.2 would give us 18 cars that have a speed of more than 85. It's only an estimate because we don't actually know the distribution within that histogram. We're just assuming that it's an even distribution. Question 12. Simplify fully x squared plus 3x minus 4 over 2x squared minus 5x plus 3. To do this, you need to factorise top and bottom and then hope that something cancels out. Well, the top is easiest to factorise. So we've got 2 brackets with an x and an x. To get minus 4, we can either do 2 and 2 or 4 and 1. But to get plus 3x's, that's going to have to be a plus 4 and a minus 1, because that will give us minus 4 when you multiply them together, and when you add them together that gives us plus 3. To get the bottom number, we're going to have a 2x and an x. Now, to make this equal to the top, so that something cancels out, this must have an x minus 1 in there. That's a real big hint, because we can't obviously have a plus 4, because then we wouldn't be able to get the plus 3 on the end of the bottom. So it must be x minus 1 in there. Now, to get a plus 3 on the end of that bottom, that must be a minus 3 in there, because minus 3 times minus 1 gives us plus 3. So that's a massive clue. Once you've got the top, it really helps us do the bottom, so we don't have to mess about as much. The x minus 1s cancel, so we're left with x plus 4 over 2x minus 3. He says, write 4 over x plus 2 plus 3 over x minus 2 as a single fraction in its simplest form. Well, to add fractions with the common denominator, so if we multiply the top and bottom of the first one by x minus 2, we would get a common denominator of x plus 2, x minus 2, and then multiply the top and bottom of the second fraction by x plus 2. So we have 3 brackets, x plus 2, and then we have that same common denominator, x plus 2, x minus 2. If we expand the tops, we'd have 4x minus 8 plus 3x plus 6, and that is over that common denominator of x plus 2, x minus 2. And then to simplify that for our answer, 4x's plus 3x is 7x's, minus 8 plus 6 is minus 2, and we've got that common denominator of x plus 2, x minus 2. Question 13. The diagram shows a solid hemisphere of radius 5. Find the total surface area of the hemisphere, leave it in terms of pi. Well, up here, we've got the surface area of a sphere. Now ours is only a hemisphere, so we're going to do a half of that. So a half times 4 times pi times r squared, and r is 5, so that will be times 5 squared. And to get the circle on the bottom, that will be pi r squared, and it's a full circle, so it'll just be pi times 5 squared. And we need to add these two together. So if we work these out, a half of 4 is 2, and 5 squared is 25, so the top one would be just 50 pi, and the bottom one would be 25 pi, and if we add those two together, we get an answer of 75 pi centimetres squared. Question 14. There are 20 counters in the bag, 8 counters are yellow, 12 counters are green. As Eve takes a random 2 counters, work out the probability of there being different colours. Well, the best way to do this one is with a tree diagram. So if we have yellow and green, yellow and green, yellow and green. Probability of getting a yellow first is 8 out of 20, and a green first would be 12 out of 20. If we've already pulled a yellow out, then there'll be 1 less yellow. So there'll be 1 less yellow, so that'll be 7 yellows, and there'd only be 19 in the bag. But there'd still be the same number of greens, but only 19 in the bag. If we pull a green out first, we'd still have the 8 yellows out of now 19 in the bag, but we'd only have 11 greens out of the 19 in the bag. Now we want 2 different colours, so it's these 2 here that we want. So to get this one, it would be 8 20ths multiplied by 12 19ths, so you always multiply down the branches, and this one would be 12 20ths times 8 19ths. Because we're not bothered which way around we get those, we can add these together. So we want this one and this one, so we're multiplying this one and this one, so again we're multiplying, and then we're not bothered whether we get this one or this one, so we add. That will give me 96 out of 380, and this would also give me 96 out of 380, which would give me 192 out of 380. Now it doesn't ask for it in its simplest form, so you don't need to cancel it down, but if you did cancel that down, you end up with 48 over 95. Question 15. N is an integer greater than 1. Use algebra to show that n squared minus 1 plus n minus 1 squared is always equal to an even number. Well, it says use algebra, so you cannot substitute numbers into this to show it, alright? You must use algebra. So all we do is we expand the brackets. So the first bit is just n squared minus 1, and if we expand n minus 1 squared, it just means n minus 1 times n minus 1. So n squared minus 1, we'll leave that bit alone, and if we expand this bit using FOIL, n squared, and then the outside's n times minus 1, and minus 1 times n will give us minus 2 n's altogether, and then minus 1 times minus 1 is plus 1. If we simplify that together, we've got 2 n squareds, we've got minus 2 n's, and then the minus 1 and the plus 1 cancel each other out. To show that it's an even number, you must factorise that and pull a factor of 2 out. So if we factorise that, n squared, 2 brackets n squared minus n, this shows that it's an even number. So we must write a multiple of 2 is always an even number. Can I just say at this point, this line here is there for a reason. You must not write below that in the exam. Alright, they scan these questions in, and if you write below that, it won't scan in your part of your answer. So please don't go over that line in your test. Question 16. It says ABC is an equilateral triangle, D lies on BC, and AD is perpendicular to BC. Prove that triangle ADC is congruent to ADB. Well, to prove congruency, we can either show that these are SSS triangles, SAS triangles, ASA, or RHS. Okay, so this one means we show that all 3 sides are the same, this one 2 sides an angle, this one 2 angles and a side, or this one the right angle, a hypotenuse and the side. Using the first 3, we're going to have to prove that either the angles are cut in half or the line is cut in half, and that's quite difficult to do. So the only one that doesn't involve a proof is the right angle, hypotenuse, side. So this is the hypotenuse, this is the side we can use, and this is the right angle here. So we just need to state what we're going to do. So ABC is equilateral. So AB must equal BC. So we've shown that AB, must equal AC, So we've shown that these two sides are the same as each other, okay, showing that it's equilateral. The next thing we need to do is prove that these are right angled. So if it's perpendicular, angle BDA equals angle ADC, which equals 90 degrees, because they're perpendicular. It's given that in the question. And they share side AD. So we've now shown that the both hypotenuses are the same. They both got a right angle in them, and they both share a side that's the same. So therefore, they are right angled hypotenuse side triangles and congruent. If you did it any other way, you had to prove that this was cut in half, and you also had to prove that these angles were cut in half as well, which is a little bit more difficult than doing the way I've done it, so although it is possible. Part B, it says, hence prove that BD equals a half of AB. So this is the bit where we've actually got to prove it. And the fact that we now know that they're congruent makes that a lot easier. So if they are congruent, which we've just proved they are, BD equals DC and AB equals AC. So BD equals a half of AB. So if these two are equal to each other, then it must be split in half. And if AB equals AC, then BD must be equal to a half of AB. Question 17, rationalise the denominator. So to rationalise the denominator, we multiply top and bottom by the denominator. So we multiply this by root 5 and this by root 5. The reason why we do that is because root 5 times root 5 is root 25, and root 25 is just 5. So it'll be 6 root 5 over 5, and that can't simplify down anymore. Sometimes the 6 and the 5 will simplify down, that's as far as it will go on this one. Expand these brackets, so we're going to use FOIL, so 2 times root 5 is 2 root 5, then do the outsides, 2 times root 20 is just 2 root 20, then the insides, root 10 times root 5 is root 50, and the last, root 10 times root 20 is root 200. Now it does say simplify this, so this one can't be simplified, so it's just 2 root 5. This one can, because it can be written as 4 times 5. The reason why 4 times 5 has been chosen is because 4 is a square number, we can square root that in a second. Again, this one can be simplified to 25 times 2, and this one can be simplified to 100 times 2. Now the reason I've done that, the 2 root 5 don't do anything with, but root 4 can be written as 2. So here we've got 2 times 2, which is just normal 4 times root 5. Here root 25 is just 5, and the 2 we can't do anything with, so it's still a root 2, and root 100 is 10, so it'll be 10 root 2. And if we simplify that all together, we've got 6 root 5s, and add to that 15 root 2s, simplified down fully. Question 18. David has designed a game. He uses a fair 6-sided dice and a fair 5-sided spinner. The dice are numbered 1 to 6 and the spinner 1 to 5. Each player rolls a dice once and spins the spinner once. You can win a fiver or win £2 with that information there. He expects 30 people to play the game, each paying £1. Work out how much profit he can make. Well, first of all, if it's 30 people paying £1, then your first mark is for knowing that it gets £30, alright? We just need to deduct from that any winnings. Now, you can do this using fractions, but it's very, very difficult. This first one is nice and easy, but this one, you've got to be very careful that when you are doing the probability of rolling a 1 and a 1 wins on that one, a 1 and a 1 wins on that one, and a 1 and a 1 wins on that one. So it's really, really important you don't count that 3 times. So I've chosen to do this one with a sample space diagram. So if we put the dice down the sides and the spinner across the top, to get a 5 and a 5, that's this one here. So that's where he wins a fiver. All the ones where they win £2, they can get a 1 and a 1, a 1 and a 2, a 1 and a 3, a 1 and a 4, or a 1 and a 5. Or you can get a 1 and a 1 again, but I don't want to count that again. So a 2 and a 1, a 3 and a 1, a 4 and a 1, a 5 and a 1, or a 6 and a 1. Or you can get both 1 and a 1, and again I don't want to count that one again. So altogether, there are 10 ways of winning £2. So we've got one lot of a fiver, one way of winning a fiver, and we've got 10 ways of winning £2. So that's a fiver, and that's £20. So altogether, it's going to pay out £25. So £30 take away £25 is a £5 profit. It says, give a reason why David's actual profit may be different to the profit he expects to make. Well, probability is a measure of likelihood. It is not exact. So even though this is what we would expect to happen, it doesn't necessarily have to happen exactly like that. Question 19. P is inversely proportional to V. When V is 8, P is 5. Write a formula for P in terms of V. Well, it says P is inversely proportional, so that would be 1 over V. So inverse means 1 over. We then need to put in the constant of proportionality, which is what we need to work out. And then we can substitute our numbers in for P. So P was 5 when V was 8. And we can use that to work out K. We take the 8 on the other side, it comes and multiply. So 5 times 8, K must be 40. So our formula is this here, just with K in as 40. So P equals 40 over V. It says calculate the value of P when V is 2. So using our formula, P would be 40 divided by V, which is 2, which just gives us an answer of 20. Question 20. The diagram shows parts of the curve with the equation y equals f of x. The coordinates of the minimum point of the curve is 3 minus 4. Write down the coordinates of the minimum point of the curve with the equation y equals f of x plus 3. Well, if you add 3 to the end, all it does is move the graph up 3 places. So the x coordinate would stay the same, but the y coordinate would go from minus 4 to minus 1. It just moves up 3. For y equals f of 2x, what this means is you would get the same value for y when x is half as big, because when we double that x, we would get the same value for y. So what we need to do is we need to half the x value, so that would be 1.5, but the y value would stay the same, so 1.5 minus 4. Y equals f of minus x means we get the same value for y when x is the negative of what it was before. So this time it's a reflection in the y-axis. So that would mean that instead of being at 3, it would be at minus 3, but it would still be down at minus 4 as it's a reflection over here. For part 2, you would end up with a graph like that, where it goes through at half the distance there. Question 21. It says A has coordinates minus 3, 0, B has coordinates 1, 6, and C has coordinates 5, 2. Find an equation of the line that passes through C and is perpendicular to AB. Give your answer in the form AX plus BY equals C. We'll forget about this last sentence for a minute, and we'll just work out the equation of the line. So the first thing we need is the gradient of AB. So gradient is given by the change in Y, or the difference in Y divided by the difference in X. So the difference in Y is 0 to 6, which is 6. And the difference in x is minus 3 to 1, which is 4. Now I'm going to leave that as a fraction, because when we do perpendicular, we want to find the reciprocal. So let's leave that as a fraction, just cancel it down to 3 over 2. So our line, to work out a perpendicular line, it's the negative reciprocal of the original line. So if it was negative, you turn it into a positive. If it's positive, you turn it into a negative. So in this case, it will be negative 2 over 3x plus or minus something on the end. So our usual straight line graph, y equals mx plus c, the gradient will be minus 2/3 x. If we substitute these points into that, so when x is 5, y is 2, so minus 2/3 times 5 plus or minus some number on the end. Well, minus 2/3 times 5 is minus 10/3 plus or minus some number on the end. So to get an answer of 2, we're down at minus 10/3. This is the same as minus 3 1/3, if you write that as it is in whole numbers. So to get from minus 3 1/3 up to 2, it would be minus 3 1/3 up to 0, and then another 2 up to 2. So this number here must be 5 1/3. So to get from minus 3 1/3 up to 2, it would be plus 5 1/3, which, if we write that as a fraction, that would be 16 over 3. So our equation is y equals minus 2/3 x plus 16 over 3. Now the reason why I've left this all in fractions is because it asks us to write it in the form ax plus by equals c, i.e. there's no fractions in it. So if we've got it all as fractions now, we can get rid of the fractions all in one go. You can see that each part is being divided by 3, so if we times by 3, we must multiply each bit by 3, so that will become 3y. This will just become minus 2x's, and this will become plus 16. It then asks for the x's and the y's on the same side, so if we take the 2x's on the other side, it would be 2x plus 3y equals 16 as our final answer.